Hi, good afternoon, everyone. Thank you for attending the webinar today. We are starting the webinar on nozzle analysis using ROHR2. So, going forward, today's agenda is introduction, Sigma and NEILSOFT. Who are the people? What is Sigma and what is NEILSOFT? ROHR2 product family. What are the ROHR2 offerings? And ROHR2 the interfaces. Then we'll go to an example with nozzle analysis with ROHR2. So, coming to the introduction, myself Gangadhar. I'm a senior consultant for the process verticals. I'm with NEILSOFT from last 9 years, and I'm in this field from last 12 years in the process industry. Coming to the Sigma, the people behind the ROHR2 are the Sigma. So Sigma, if you see the Sigma offerings, they are into software development, software sales, software training, software support, and they also do the engineering services. So these people better understands what is the criticalities and the stress. So they implement the same thing onto the ROHR2. So that will become a part of their delivery in all the whatever the upgrades it happen. So Sigma, it is situated at Germany, a place called Unna. There are 18 engineers who are working in the Sigma with two different domains. One is the software development, other is the engineering services, which I was telling about. It was founded in 1989. So initially that ROHR2 development, whatever so ROHR2 takes care of the development. Also they do the trainings, hotlines, engineering activities. These people became the development and distributor partner from since 2000. So if you see the software development, what are the engineering activities? Yes, when it comes to software development, they have the different kind of products called ROHR2, which is static dynamic, and in the part of that we have ROHR2 nozzle, ROHR2 flange, then the ROHR2 FEM, ROHR2 stars, ROHR2 ISO, CNS for the pressure drop calculations. Then when it comes to engineering, so they do other things like internal pressure design, special component analysis. So what is the purpose of the software? If you see that, what will the ROHR2 handles for? You can do the internal pressure design. You can it is all inbuilt with the different types of codes, standards, pre-built settings, all these kind of things. So then looking forward, the NEILSOFT. We are the sales partners for the ROHR2 in India. So if you see that what is our core strength of the NEILSOFT. NEILSOFT started its operations in the 1993, and our focus is to make the people more efficient by using the engineering technologies and adopt the same thing for the engineering activities in day-to-day life, and they benefit more from the product technologies. So we have our technical and delivery centers in the Pune, Ahmedabad, Frankfurt, Appleton, all these kind of places. Then when it comes to sales offices in India, we are in Pune, Mumbai, Ahmedabad, Delhi, Bangalore, Chennai. So we are the sole resellers for the ROHR2 in India, and we do the ROHR2 sales, trainings, workshops, webinars, all these kind of things in the India. So looking to our customers, we have the customer list, like you can see that Alstom, BHEL, Technip, Jacobs, Covey, Babcock, many more. So when it comes to the ROHR2 product family, which I was telling you that the software development and engineering, when it comes to ROHR2, it can do the pipe static and dynamic analysis. In the pipe static and dynamic analysis, you can do the component. When it comes to the whole pipeline analysis, you can do that. You can put out the support loads and you can do the extreme value calculations. Then you can create your equipments, and you can you can route the pipelines, and also you can support with the structural members on the same thing, and you can go for the different types of load cases. When it comes to load cases, I'll just show you in the other slides what type of load cases you can utilize during your analysis. and what are the benefits you can get from that. And also the ROH2 has a one more vertical which is like a ROH2 isometrics. Some people where they don't have any kind of detailed engineering software, where they want to do directly the pipeline routing and they want to generate the isometrics, they can get the nanoscale isometrics with total BOQ directly from the ROH2. ROH2 FEM is for the component analysis. If you have any components like a T, elbows, spring, whatever it might be, you can do the ROH2 component analysis for that. So in the ROH2 starts, you can do the dynamic analysis like with a fluid hammer, all this kind of thing. When it comes to a CNH, flow distribution, pressure drop calculations, you can make it. These are the ROH2 offerings. So what ROH2 can do for us? So when you are going to do any kind of, you can give the inputs. So internally ROH2 will, by pre-settings and your configuration settings, it automatically calculates and it displays the outputs in the form of documentation, in the form of GUI, in form of the external interfaces and all these kind of things. When it comes to, you can see that even you can also, whether you can do manually the pipe routing, or you can, if you have any type of interfaces with, let us say with the Aviva PDMS or Cadison, you can take the line routed in the Cadison directly to the ROH2 and you can do the analysis and you can output in Unify now. Likewise, if you take Aviva, you have a bidirectional interface. Whatever the line you modeled in the PDMS, you can directly transfer in the neutral format to the ROH2. You can put out your load conditions on the same thing and you can extract the documentation from that. And if you do any kind of modifications on the line which you have imported from the PDMS, you can send it back directly. We have a bidirectional interface with the Aviva PDMS. ROH2 overview. So it was first used by MVP Dortmund in 1968. That is what we are telling. It's more than 50 years now. So available on PC for more than 20 years now. We have a first graphical user interface from 1994. Then SIGMA became a license for the ROH2 since 2000. So this is a ROH2 Windows graphical interface. How it looks. You can see the ROH2 window graphic interface where you can also preview whatever the model is there. You can just go to each component and you can preview it. You can see that what are the dimensions been used in the system can be seen. You can see that what are the configurations you are trying to make for each component you have made done. Then apart from that, even if you want to make anything, any system is there, that system is supported with structural members and you want to do some analysis on the critical parts, that can also be done. It considers the stress rigid members and it calculates automatically the stress analysis for that. If we come to the material data, if we come to the what are the pre-existing databases, we have it. We have materials, all English, ASME, structure, steel works. We have different types of steel members, I-beam channels, all these kind of piping components of different standards, spring supports, different types of manufacture like Lisega and many more. Expansion joints of different types, lateral, angular, axial, all the types are available. So when you can, this is a small snapshot I have shown you that where you can pick out your lateral support and you can place it. So you can so for each lateral expansion joints also we have different manufacturers that are pre-built. Even if you want to make your own database for either for the materials or either for you want to create your own this kind of expansion joints, you can, yes, you can straight away you can input the parameters for that and you can create it also as well. So different types of load cases. It starts with the dead load, then thermal expansion, then you can have the different types of occasional loads, wind, earthquake, many things, and then you can also go for line loads, point loads, eigenvalues, all the dynamic loads. Then you can go for the superposition of all the loads, which we say that extreme value calculations. So it directly picks from the superpositions. Stress analysis. You can calculate all allowable stresses. You can also get the superposition and all the equation automatic diagrams. I meant to say stress utilization. So it will give you the where is the stress utilization factor with a representation with a graphic. So even for the each support loads, if you have it, you can also find out the superpositions. Even if you want to create any kind of equipment, you can create those equipments, and you can also create, if you are creating any equipment, and if you want to do any WRC analysis for the nozzles and all, you can do that one directly with the ROHR2. Even if you want to create any calculation for the GRP pipes, yes, possible. For the jacketed pipes, even for the buried pipes, whether it might be nuclear or any kind of things, we have a pre-built standards, you can follow that, and you can go for the analysis. And also one more thing, if you want to create a different system, not for a single line, if you want to create a different system, for different systems also you can create it, and also you can give the caloric representation for each system. We have that kind of feature in the ROHR2. Then when it goes to dynamic calculation, we can do the fluid hammer, load time functions with the frequency, acceleration, and all these kind of stuff. Results, yes, when you go on a part by part or any kind of a results, forces, movements, rotation, displacements, equivalent stresses, additional results, which I was telling you that when you go for the spring design or any extreme value calculations, you can also find out what are the support loads on each entity. Automatically it gives you the results for those things. So expansion joints, if you have created any expansion joint, you can also get the documentation for that on those kind of, what are the stresses and all those kind of. This is what we are saying, that when you go for the stress analysis caloric representation, if you start from 0, which is a blue color, which is like a stress free, and when it comes more than 100, then the stress utilization factor is high. So based on that, we can optimize our pipe routing with by changing the material or by changing the standards, all these kind of things, and you can optimize, and you can again check it for your stress analysis calculations. So you can get, once you have modeled the pipeline in the ROHR2, if you want to export it in the form of a DXF for your reference or to give it someone, yes, you can do it. Then it in the form of ASCII format you can give it, which I was telling you, you can see and you can give it. And again in the RTF and PDF, you want to the document submissions, if you are there, so you can do the documentation in the form of ROHR2, RTF and PDF kind of a format. So this is how it looks. So I have routed a one pipe model. Then you can see that, and even if you want to make it in a different views, you can make the visibility in the different views. So I am applying, even if you want to do some cold condition, if you want to apply, you can apply the cold conditions where it is a, then you can go for the analysis. Finally, if you want to make any dimensioning for your isometrics, those can also be done. So you are looking for your stress analysis. So where there is a red color, it is the stress utilization factor is very high. So you can go for a quick optimization on that. Later on, if you want to put any documentation, for you want to put all the graphical text for understanding the people, so you can put out the directly on the model itself with the graphic text format, so that when you take it on a DXF format or any kind of format, that will be readily available for the people for the easy quick references. So isometric, this is what we have, different types of when you are generating an isometric, we have like how the dimensions can be happen, whether between the spring supports, the dimensions to be vertex to vertex, all these kind, you can set it. So you can put it, and you can put a graphic text, and you can export that in the form of once you DXF, and also bill of material in the form of PDF or TF. Even if you want to export, you can export in the form of Excel. What is ROHR2 FEM? FEM is the finite element methods. For what components you do that? T, nozzles, bends, vessel bottoms, all these kind of thing. Yes, with ROHR2 FEM you can go for the finite element components, so that you can get the documentation in detail on this kind of stuff. Then the CNH for the flow distribution, pressure drop and temperature drop in the branched segments. If you are doing any cross-country pipings or any kind of thing, systems, intermesh piping networks, this will help you in standardizing your pressure drop calculations, and also Siemens have the capabilities like all the determination coefficients for bend reducer, T, restrictor, regulating valves, and you can also perform different load cases for pumps on off, valves open close, different states of operation with loaded depending on mass flow, pressure, temperature. The pumps, fans, everything will be inbuilt with the library. So whenever you want to use it, you can directly call those components, put out those components, and you can go for that, and you can put out a condition. So this is how it looks with a branch network with all the data. You can see that pressure temperature curve. So this is how it displays the results finally for you. Results on section like a flow, velocity, pressure variation, temperature, heat drops, temperature, insulations, all those kind. On each different nodes, you can able to find out the pressure, temperature, flow, density, viscosity. So this is one of the system. Finally, to preview or to print, 2D view for the P&ID and 3D view for the isometrics. Color representations you can mention it. Presentation of results for all section nodes. So finally, when it comes to the interfaces of ROHR2, yes, which I was telling about. So you have one line which you want to bring it, it's in the form of a neutral format. You want to get it to the node 2. So directly you can see that even for the with BMP, you have an import, all those kind of directly you have that. You can apply the pressure and temperature conditions with the density of the fluid, and then you can go for the quick analysis on the thing. If you have anything predefined material in the CAD systems like PDMS, Cadison, or Intergraph, whatever might be products, so the material also will be taken consideration directly with the mapping database, and it imports into the ROHR2. Even if you are given pressure, temperature, those conditions also will be taken. Only the operating even if you have defined the operating, just you have to assign the operating conditions for whether it's a cold piping or whether it's a full open pipe from start to end. So you have to just select the segments and you have to go for the analysis. So even once you get in the model with the interface into the ROHR2, you can just check it out. Even if something material missing, even if you want to add extra things on the if some material is not defined for any kind of elbow or any kind of a T or something, you can define it in the ROHR2 and you can go for the component, the pipe stress analysis. So these are I have just put up for your snapshots. Like we have different types of ROHR2 interfaces: ITN Factory, Cadison, Aviva PDMS, Intergraph PDS, Isogen PCF. Additional interfaces also are there. So we can also do it for you if you have any kind of a company specific software is there. If we have something a development, yes, we can consult our OEM and we can create an interface and we can deliver it to you. So when you work with the ROHR2, all this less time you needed to do for do the calculations. Yes, it results in high quality improvement. Then we'll come to our product, our webinar today on nozzle analysis with ROHR2. So first, we'll put up a questions like this. Why do we need a nozzle analysis? Yeah. So because we want to compare our calculated pipe loads against existing allowable loads. Which components can we analyze? Pumps, vessel nozzles, heat exchangers, etc., compressors, all these kind of turbines. What exactly does ROHR2 nozzle do? It calculates allowable loads according to the selected standards and comparing them with against loads from on our pipe stress analysis. So just I put up how the ROHR2 nozzle analysis can be done. Just a pump, a centrifugal pump, where is the suction and where is the discharge. I'm just showing a representation here. Yes. So what are the when you are doing some calculations and standards, what are the calculation standards are inbuilt with the ROHR2 nozzle analysis? Yes. If you see the steam turbines and compressors, we have NEMA standards, SM23, API 617, DN EN ISO for the steam turbines and the rotary. For the compressors, we have DN EN ISO 104. Then when it comes to pumps, API 610, DN EN ISO 13709, ISO 5199, ISO 9905. When it comes to heat exchangers, we have API 661. So when it comes to general vessels, so we can directly do with our nozzle spec. Even if you want to do any kind of a manual entry for the loads, you can directly put out the manual loads. Both directly takes from the standards, and few are the few things where user can define the loads. So if you just see that features, we have different types of pumps are as per the standards. So these are all pre-built pumps, heat exchangers, vessels. You can choose from your already defined nozzles in the ROHR2 model. Once you have created a model directly in the ROHR2, when you go for the nozzle analysis, you can already the nodes, whatever it is been listed, those will be readily available. With the existing nodes, you can select and you can say that okay, these nodes are connected to this section of the pump, and this is a discharge pump, or whether it might be a heat. Those are connected to the nozzles. Those might be connected to the vessels. Then load cases and superpositions are defined automatically once you do that. Finally, what is the desired result you will be expecting? As a documentation, yes, it can give you the documentation with all what is the what are the stresses. Even you can also have the graphical. This is what I was telling you, that the graphical representations are in pre-built as per the standards available. So ROHR2 nozzle module integrated into ROHR2 model, selection of nozzles and standards. You can adjustment of superpositions. You can do that. You can also, if you already ROHR2 and you want to do only nozzle analysis without independently, yes, you can start a nozzle analysis independently without connecting to the ROHR2. That can be done. So here I'm just showing you a snapshot where the vessel is a vertical vessel and it got a head and the vessel. So you can see that here I have just chosen the what is the nodes, and I have assigned, okay, these nodes are connected to the vessel type and these are connected to the head type. And also here I'm putting that whether in watch position. The vessel has been created with the vertical, so I'm putting it. If the vessel has been created in the XYZ in the horizontal direction, I can put X. I can select all those kind of stuff. So if it is a pump, there we can define what is the type of, whether it is connected to a suction, whether it is connected to the discharge. Finally, you can go for the analysis, for the nozzle analysis. Then you can also view the output files, and you can also get output in the form of RTF or PDF. So you can integrate the whole thing for your pipe stress report. So what it can do, so increases your productivity. All these are whatever you are using the ROHR2 and its interfaces, those are field tester interfaces, completely interactive GUI. The modification or optimization for any kind of a line or something, it's very easy and all leads to your quality improvements. So let's go live now. So I'll take one of the example here. So I'm opening with the ROHR2. One example where I have modeled the line with where it has been connected with the pump. So I can put it in different orientations, X, Y, Z, all these kind of orientation. Yeah. So you can see that my X, my Y, and my Z here have different thing. Even if you want to rotate it, yes, I can do that. So here if you see that in this portion I have a pump where I have one end is connected to the suction, one end is connected to the discharge. This. So now let us say that okay, we'll quickly for this pump whatever we have created, we have a node. We have a node 47 which is connected to suction, and node 53 which is connected to the discharge. So we'll go here and we'll go for the load conditions here. So we'll go for the nozzle analysis. Let us say new. So you can just see that the nodes whatever these are connected to the heat exchangers, the B, these are connected to the vessel I have defined, This is the this is we have seen now. Okay, 47 is my suction, and 40 I have defined 53 is my discharge, right? So now let us select only the suction and discharge and say. So you can also see which type of pump yours. This is what I was telling about. This is the pump exactly. Yes, this is the suction pump, and it has been connected to a discharge. So we have done, and I can define it pump. And here is a suction. So when I connect here, I can say suction. So you can see that the forces are coming here directly from there. This is a discharge, and say okay. Yeah, I've done, and I can say okay now. So let us go for calculation now. You can see that I have given one nozzle analysis. I can just say okay, calculate now. Yes. So I have a results now. So I can go with displacements here. So I can see that some of the displacements here with the dead load, with the operation load, what are the displacements which is going on. Even I have put up the wind displacements. You can see with the wind load displacements in the x direction and the y direction. There is a system which I am calculating. Okay, yes. Now what I want to do, yeah. So I made a calculation. Now I can go here and I can say view output file only for nozzle analysis. This is how you'll get a documentation. So when it comes to here, this is the pipe of pump which we have used. You can see that API 610. So this is the nodes which we have defined. What is the diameter, what is the section, what is the forces, you can say allowable, factors for allowable. So it automatically calculated what is the stress utilization factor. Yes, we got some here the forces as well as the moments. You can see that then in the MY we have something called 820, which is like a very high utilization factor. So we can just go and we can also do some optimizations here. So when we go here and go with the dead load only, no problem. So let us put one. So let us see that how we can put out the expansion joint, because you can see that there is something which is 820.8, which is extremely high. So I'll help you out in these things. Okay, you want to go ahead? Yes. So I'll go with the library. So I can also put here in the form of vertical, because it's in the vertical direction. So you can see now. Then I can save it. I'll go for all. I can say no problem. So it was 820, right? So I try to put some lateral expansion joint. So then became 304. How you can make your optimizations based on the selected components and putting it in the where the displacements are there. So likewise, you can also put out your the expansion joints in that kind of tie rods in that kind of direction. So it can give you. So then we'll go. This is how we can do the pump which we have added for the nozzle analysis. Likewise, we can also add now. We have other things. So let us take our heat exchanger. So we have a heat exchanger. Let us say that the heat exchangers are getting in the loads from ROHR2. heat exchanger. So no need to define these things directly, it's that. So I can say okay. Now I have defined this. So now I can go here again and I go for this nozzle analysis only. So you can see now for the heat exchanger allowable loads, it has taken the predefined in the forces and moments based on my dead loads and operation loads. I have given the forces and moments on that, so it has taken those into the considerations and it has given the. Likewise we can go for say all, and we can see fine. Likewise we have a here our vessel. So if you see that I have constructed in the form of the vertical direction here. So if you see that my the node 15 and 9 is connected to vessel, but 17 is connected to the head. So I'll go to the nozzle analysis again and I'll say new. These are the new nozzles, I have it, and I'll say it gets the from the nozzle spec. So I'll put vessel. So now I want to define it. So you can see that my vessel has been put in the Z direction. Yes, so I'm just defining that one. So you can see that here it is in the form of vessel. So I'm putting in the vessel. So this is also connected to a vessel. Whereas if you see this, the 17 that is connected to the head. So I can define my head like this and I can say okay. Now I can go for a vessel is also been added into this. So where what has been connected to where, position, and all these things approximately. So there again it is showing that utilization factor is very high. So you have your own methods. We can create one loop and then we can try to optimize the utilization factor in that which has been connected to that nozzle. That will make you lie. So even now if you want to have a results and if you want to have a documentation, everything in the RTF format, so you can choose okay, mine is the English. You want to consider everything. So now we'll create a documentation and all the reports we can create it. So even that is what I was telling about. Even if you want to go to the isometric mode later on, you want to give your dimensioning, all this kind of thing, whether you can give manual dimensioning or dimensioning automatically. This is what I was telling about isometric, whether you can give vertex to vertex or with the supports, everything. Even you can define also what is the distance between each. So it automatically gives you the dimensioning. And the same thing when you want to export it, you can also export it in the form of DXF format for your reference. And you can also print in the form of all the prints you want to have it, or you want to have individual summation, all this kind of. So I have a converter here. Let me put into the PDF format. So you can see that, okay, this is what I have made a dimensioning. You are getting a full your analysis, and you can also get all your pipe, what is the material being configured and what is the dimension of each kind of a thing. So likewise you can make a documentation. So this is one documentation. When you go to the results, so you have even if you want to go to any sectional results also, you can go in and you can also go in the sectional results. You can see that you have a different types of node, and you can see that what is the forces and moments on each. So like even if you are going for the dead load, and if you want to see that even for only dead load, you can see also, because I was telling you that it automatically considers the extreme value calculations and all. So it lists out all your things with the extreme value calculation. This is what the dead load you can get a output format. Select the report template. Even if you want to edit the report template, you can also edit the report template. So you can say create report now. So it is a total, even if you want to customize your report with your company logo, all this kind, yes, you can do that. In the report template, you can directly go there and you can. So it's a predefined report. So you can see that, okay, yeah. So this is the system which we have created now. It is showing that what is the, because the name, whatever I given it, it is showing that in the name. So what are the pipe sizes we have considered? What are the defined pressure temperatures? The components, expansion joints. So I have used one expansion joint, what type of expansion joints and all this kind of stuff. So load cases, what are the different types of load cases? I used here dead load, operation load, and one occasional load, which is a wind load. So you can also see that what is the theory of calculation for the each type. So spring design reports, what are the reports springs we have used, and you can see that. Then finally, what is the stress evaluation for each pipeline. So you can see that the one on the secondary loads which is high, where we can try to optimize below and make below 100. It's okay right now. This is how you can make your whole documentation, as well as the part by part documentation for each nozzle analysis. If you want to do, yes, the only the nozzle analysis you can do. I can go here and I can say update a table. So you can see now for each. So quickly we'll go back to our presentation and see what we have done on the nozzle analysis. So I'm just recalling the things what we have done now. So we want to compare our calculated pipe loads against our allowable loads. So which components we can analyze, all the pumps, vessels, heat exchangers we have taken and we have analyzed. What exactly we are doing with our ROHR2 nozzle, it calculates allowable loads according to the selected standards and compare them with the loads on our pipe stress analysis. This is what we have done. And what are the availability of standards? So these are all pre-built standards which are the supply of through the software with the Sigma. Steam turbines and compressors with different standards. So when I am selecting a pump, I have chosen the standard type as a 610. So when I am selecting the heat exchangers, I use as like a take it as a allowable loads because I want to give you the different approaches. One of the equipment manufacturer is there. He want to use his own nozzle spec for his stress analysis. He can do that. Okay, one of the heat exchangers is based on the system. He want to go what type of allowable loads to be considered. So based on that, when it comes to a centrifugal pump, I directly chosen as API 610. So whatever it is been defined as per the standards. So it's all your availability. Just I have shown you the different types here. Whether you can be like by the default standard, you can select it or whatever it might be. Manually, you can even if you want to put manually also, you can do that. If there is any equipment manufacturer, he has created his own vessel and you want to do some analysis only for that equipment with a nozzle, then he can enter his loads manually on each nozzle so that he can go for the nozzle analysis and he can get the report. Features, yes, I have shown you that as per the standard availability, API 610, all these things, the graphic illustrations also been present. Even this is what I was telling you, that if there is only the equipment manufacturer, he no need to open anything. Directly he can go and he can open ROHR2 nozzle.exe, that this module will get open up so that he can do his analysis on that. But it will be a part of a total software only, but he can run independently of that with this. So here when it comes to vessel, we have chosen what is the direction of the vessel being constructed, whether it's a vertical vessel or the horizontal vessel. Based on that, we have selected the component axis. Then we have also chosen for the nozzle, how it is, whether it's a head, whether it's a vessel, all those kind of stuff. For the pump, we have given suction and discharge, so automatically allowable loads. This is how we have extracted our reports, one in the RTF format. So the same thing, it can also be integrated to the pipe stress analysis format. So this is the documentation, you have got it. So yeah, this is how we do the nozzle analysis with ROHR2. So I just want to give you the glimpse how we can do this through this webinar. I think this will be very helpful for you in day-to-day life if you want to do any kind of nozzle analysis. This is a inbuilt feature in the ROHR2, so you can directly start going with a ROHR2 nozzle analysis if you want to perform to do that. Yes, if anybody interested in kind of a detailed demos or this kind of stuff, you can contact us so that we can come and we can present you the software. If there are existing customers, yes, we can come and we can do some advanced training for you so that you can use the tool in a better way, and you can obviously you can gain your improvements with these things. Thank you all for attending the seminar. Thank you very much. I'm signing off. So you can give us all your feedback to us. Thank you.